We mentioned earlier the speakers are the most important part of the audio system. The reason for that is simple, because it's the only part that converts electrical signal into mechanical movement or mechanical waves or sound what we hear from the speakers. And it's the most difficult part to design to achieve high fidelity and because of the complexity of the sound conversion. In general, there are different types of speakers, and mostly people characterize by, say, the number of drivers used in a speaker. So the simplest one is a single driver. It's also called full range speakers. And the most representative brands are CAV or Tannoy, and they have some good sounding speakers. However, because it's only a driver, and then the problem is that how to achieve, the low frequencies and high frequency, how to balance it become very complicated, and it's hard to achieve a very, very good full frequency range response. When we say full frequency, it's about 20 hertz to 20 kilohertz, which is the range that our ears can hear. And that's the reason people will start to pursue more drivers. For instance, in this case, we have a 2-driver speaker. This is a Dynaudio 2-driver with about 8-inch woofer and then with a smaller tweeter. And you can see that the woofers are normally bigger because the larger the size of the speaker, the lower the self-resonance frequency, and they can sound deeper in the bass area. And for tweeter, you need a smaller diameter in order to achieve the higher frequency. Just like when you look at the drums, the bass drum is bigger because cells frequency is lower, and some other tom drums or whatever will be smaller. And that's the nature of the physics. And then there are 3 driver speakers. We call it 3-way or 2-way, 2 drivers, 3 drivers called 3-way. The difference is that in terms of designs, 2-way is simpler than 3-way. You can imagine, right? You only need one crossover to separate the tweeter power from the woofer power. And basically for the tweeter, you just need a high pass filter to go to the tweeter. So you filter out the low frequency content and make it more dedicated to high frequency, and also to prevent damage of the tweeter. And then the woofer, same thing, you just get a low pass filter to have only the low frequency into the woofers, so that there's you can avoid their high frequency distortions and so on. The reason most people will start to look into 3-way is 2-part. One is that 2-way, you can imagine, once you divide it into 2 parts, the frequency response, the way you can time it, become less flexible. For example, the famous Rogers 35A is a 2-way. In order to have a flat response, they need a very, very complex crossover design. And the complex crossover design will make the speaker cost more, but most importantly, the dynamics and the frequency response and everything will be compromised. And especially one thing, if you look at the speaker box, basically it has a phase with the width and height. There's the effect called diffraction. So the sound propagates from the front of the speaker. When they wrap around at the edge, they tend to have certain the diffraction effect. Just like you drop a stone in the water, you can see the wave propagate all the way. But when there's some barrier, you can imagine that the wave will propagate a second time, generate a secondary wave and interact with the main sound. And that causes some baffle effect. And that baffle effect is very hard to eliminate in a two-way design, but it's much easier in a three-way or even four-way design. And that's another reason for the people to pursue with more speaker drivers. And another reason is that because more drivers help you to divide the frequency range into different more sections, and that way the speaker may handle higher power as well. So those are the main differences between, say, a single driver, two driver, three driver, and so on and so forth. And then the next key question pop up will be, why on the market only a few percentage of the people or very few people really pursue high-end speakers? The reason for that is mostly because our hearing has not been adapted to a high-end sound. Also for this reason, you can see a lot of relatively low-cost manufactured speakers can, win a lot of customer, and by just doing some simple design to make a sound like a favorite ear, like a Bose is a very good example, right? So the drivers are relatively low-cost drivers and so on. So they try to tame their sound to make people feel good at the very beginning. The reason is our ears, before they are well trained, can relatively insensitive to discern the minor differences between different instrument and different sounding vocal and so on and so forth. And therefore, for many of us, when we started to look into speakers, it's hard to tell the differences between high-end versus low-end. A lot of low-end sounds even better than high-end speakers. And that's the reason the high-end speakers are not a large market kind of product. And of course, second reason is the price, right? Normally high-end speakers are very expensive. For example, these ones sell for 10,000 per pair. These are relatively old and original when they released, and these are more like 5,000 and so on. But once we started to be more into the speaker, the audio systems, we start to train our ears to be more sensitive to the details. Or in other words, we might want to train our ear by ourselves, right? Start to say, understand the sound of different instruments, like how a guitar should sound, acoustic guitar versus an electric guitar, or how a drum should sound, and how a violin or piano or a keyboard or vocal, right? Female versus male. And we start to look into it until we understand those type of sound. Our ears will be more sensitive to discern the minor differences between the speakers and the audio system overall. So that's a kind of decision you want to make, whether you want to hear that differences or I'm totally okay just with the generic kind of speaker sound. because it's totally fine. A lot of people don't have the time to spend on those minor details. It's like cooking dishes, right? At the very beginning, our taste is not that sensitive to the tiny differences, to tell the tiny differences. And we might be just attracted by, say, some spicy thing or some very excited kind of taste, you know, like sour or whatever. So at the very beginning, we might be attracted to those kind of things, right? But after a while, right, when you try different style cooking and try, you know, different kind of restaurant, and your taste becomes more and more sensitive, and then you start to appreciate, right, the raw material, the quality of the raw material, the quality of the chef, how they cook the material. And similarly in audio system, same thing, right? Once you become more sensitive, then you become more picky on the speakers. And then come back to this question again. So what kind of speaker should I choose, right? There's so many brands and so many different kinds, 2-way, 3-way, and so on. This become difficult because at the beginning, our ears not so well trained. We pick something we like, and then soon after, when your ear becomes more trained, and then you become pickier, and then you upgrade the system and continuous upgrade. So that's very, very typical phenomenon in the audio system. It's called kind of like a fever, right? So many people just think, why don't I just say directly jump into the right piece of equipment? So this is kind of a hard answer because different speakers, different brand, they have their advantages and disadvantages. And most of the time, the speakers, even the most highest quality speakers, are not perfect designed. So for me, I would choose, say, from the very basic, whoever make the best driver. With a very good driver, later on I have more flexibility to tune it to the best sounding. So in this system, you see both of my speakers are Dyne Audio. The reason I picked them, Dyne Audio is famous for very low distortion, the driver very high quality. They're from Denmark. They have been quite some time, over 50 years. I think it's 70 years or whatever history. So they know how to make a good driver, low distortion, flat response. So to start with, and then based on that, I start to modify my speaker to make it even better. Because most of these speakers, if you look at the online measurement later on, I will show you some measurement curves on these speakers. They are kind of not ideal, or sometimes even far from ideal, even though they have good driver, good sounding. A lot of people start to look into the different amplifier to make their best sounding, but the fundamental thing is their design is not perfect either. So even the best sounding, right? For instance, the Dyne Audio, I'll show you the curve. Another famous brand is BMW. It's very well selling kind of speaker, but when you see their measurement, the frequency response is very bumpy. So there are lots of room to improve. But again, it's just like a dishes, right? When you start to looking to hearing them, and it sounds good, very, very good, because it's just like you put some seasoning and whatever. But long after you start to hear the deficiency, right, of a certain speaker, even very, very high price speakers. And this is very much I want to share. Here is an example I like to use to explain the original design deficiencies. So the top left chart, you can see this is the frequency response measured on a pair of Dynaudio DM210, the one I just showed you. You can see basically there are a few areas are not ideal. For instance, starting from 300 Hertz up to 1 kilohertz, you can see the frequency climb up. And this is the baffle effect, the diffraction effect we mentioned earlier. It's not very well compensated. And then there's a bump at around 1 kilohertz, and then it starts to droop, and around 2200 hertz also there's another bump, and then continue to droop along a long frequency range. You can see this sensitivity is much lower than this area, and then particularly beyond 10 kilohertz we can see a significant droop of the frequency response. So these are needed to be improved. And on the right hand side, I just show you the original crossover design. The high pass filter is a 10 microfarad, and then shunt with 0.35 millihenry, and with padding resistor circuitry. And the low pass filter, they use a 0.7 millihenry inductor, and then shunt with 15 microfarad capacitor in series with a 3.9 ohm resistor. And the way I modify it, I didn't change too much on the high frequency, except we want to bring up this frequency range response between, say, 10 kilohertz and 20 kilohertz. So this is the very high frequency range. You will feel the area of the sounding. So the way I did it is I use a slightly larger padding resistor in parallel with a 2 microfarad capacitor, so that it will bring the frequency response as shown in the black curve. By the way, the magenta curve is the original frequency response in simulation, and the black curve basically, you can see, boost up the frequency response and make this curve more of a flat response. And on the low pass filter, I use a larger inductor so that we can tame down this mid-range frequency response to remove this climbing effect. And in this way, we can say flat this frequency response more to the level at 88 or 87 dB range. This will cause slightly lower sensitivity, but the response is much smoother. And then we have a slightly dip in our new design to compensate this part. Again, this hump is also caused by the baffle diffraction effect. And then we bring this up, basically bring up this range, and so that we have everything back in a more flat response. So this is how I did the modification by comparing the original measurement with the simulation between the original design versus the modified design. So I tweaked the modified circuitry in order to achieve this black curve, so that we bring this curve back to a flat response. So this is how we start with reasonably good speaker drivers, good brand, and then we modify it to the best we can do. Thank you.